Hello guys, in this class now, let's now take some series of classes on integration. We just concluded differentiation. Now let's integrate. Now, but I want you to have this mindset, a clean mindset on your head that when you want to go forward, you differentiate. When you want to come back to where you started from, you integrate. Is that taken? So differentiation is going forward, integration is coming backward to get that question. So this will practically be our lesson 1. Let's start to introduce the term integration. Now, what's the introduction to integration? We first of all said that the calculus was developed by 2 scientists, and we said it was Gottfried and Leonard, right? And we said that they differentiated calculus into 2 parts. We have what we call the derivative, also known as the differentiation, and we have the antiderivative, also known as the integration. So calculus has 2 parts. So we have done differentiation. Let's now do integration. We said that you differentiate like this, while you want to integrate, you do like this. You come back to where you started from. Now, the first thing we have to do is that, first of all, I would like to know that integration is divided into 2 parts. We have what we call the definite integral and the indefinite integral. Now, I want to talk about indefinite integral. Let's say, for example, we have integral of x dx. I want to talk about definite integral. We have integral of integral of dx dx a to b. When you see this number like this, a to b, talk about definite. But when you don't see this, it means no boundary. I will explain why it is so. Are you with me? And anytime we differentiate, we always have like a constant. Do you get? Let's say, for example, we have 2x plus 5. If you differentiate this, what are you going to have? You're going to have, let's say, 2, right? Now, if I want to get back my answer, I'll get back this 2x, but I can't get this 5. So I'll just put, when I'm integrating, I'm going to put plus a constant. I'm just telling you. So you always add a constant to it. We're going to talk about that, but that's your thing. Differentiation, integration has 2 parts, the indefinite integral and definite. So when you see anything of that nature, not the one that is indefinite, but they have same laws. Do you get? Now, practically, let's now take the laws of integration. Normally, we're going to talk about laws like your power rule. We'll talk about your differential system. We'll talk about your integrating ax plus b raised to power n. We'll talk about your integration by use substitution. We'll talk about integration by fraction and by changing variables. We'll also talk about trigonometry. Trigonometry, we have like a 3-party trigonometry. So we're going to talk about trigonometry by identity. We'll talk about exponential. We'll talk about integration by parts. Of course, we're going to talk about definite integral. Also talk about integration by by partial fraction. So the classes are so plenty. But let's start with the first guy. Now, if we're going to start this guy, let's introduce the word integral. Now, anytime you see this sign, it is called integral. Are you seeing that? Or we call it this is our antiderivative and this is our derivative. So they always go like this. This is called antiderivative, this is derivative. So antiderivative, we always cancel derivative. They go together. So you must always see integral of that. This is called the antiderivative, but this is called the word derivative. Just know about that, okay? I'm just showing. From here now, I can decide to say antiderivative cancel derivative. What am I going to have? X. Are you seeing that? But I'm going to show you things of that nature. We'll just keep that first. Just know. Now, let's start with power rule. Our power rule states that, let's say we have integral of s raised to power n dx. So what does it do? To tell you that, remember that, what do we do in differentiation? If we have y is equal to s raised to power n, what will be y prime? Y prime particularly can be n s raised to power n minus 1. Are you seeing that? In this one, we subtracted from the power. But when you are integrating, you add, in differentiation, you do n minus 1, but integration, you add 1 to the power. What you do to the power, you do to the denominator. For example, this will practically be integral of s raised to power n dx. Now give me what? S raised to power n plus 1 all over n plus 1. Are you seeing that? So integral of x raised to power n dx will practically mean s raised to power n plus 1 all over n plus 1. Are you seeing that? So let's start with the first guy. Power rule now. If you know what power, let's just be solving question. By the time we solve question, you will understand. Let's start with the first. We have integral of 2x dx. Now, practically, this now becomes, let's write the integral of 2x dx. Now, the first thing to always do, my people, bring out your constant. What I say, bring out your constant. 2 is a constant, right? So this now becomes 2 integral of x dx. Now, what's the power of x here? Open that the power of x here is 1. So this practically be 2, according to that power, bracket open, s raised to power 1, which is the power plus 1, all over 1 plus 1, bracket open. Always put your constant plus c. Are you seeing that? So this practically becomes 2 x squared all over 2 plus c. If these two cancel it, what are you going to have? We're going to have x squared plus the arbitrary constant. So that's the answer. So now let's prove something here. Normally, let's say we're given a question to be, maybe they give us y now to be x squared plus 5. They have to differentiate. That will be y prime here. Y prime now will give me what? 2x. Is that correct? Now, that 2x was what we integrated now. Are you seeing that? When we integrated 2x, we got x squared. But, here was 5. The constant can be any. That's how we put c. C talks about the constant. You don't know what the constant is. Do you understand? So that's practically what it is. Let's take another example. We're giving integral of x raised to power 5. This now practically becomes integral of s raised to power 5 dx. There's no constant here now. So since there's no constant, it now becomes, what's the power of 5? So that becomes s raised to power 5 plus 1 all over 5 plus 1 plus the constant. So that becomes what? That will practically give me s raised to power 6 all over 6 plus c. This practically becomes what? The answer. Do you understand? Let's take the next question. We're giving integral of that. This now for dx. Now, this is us saying, the first here, this is something as saying, bring out the constant. That becomes 4 integral dx. I can solve this in 2 ways. Now, first of all, number one way I can solve this is that I can tell you that this is the same thing as saying 4. This is derivative, right? This is uncle derivative, this is antiderivative. If both of them cancel, what am I going to have? I'm going to have 4x plus your constant. Or you can decide to say that this is practically the same. If they have integral of 4 dx, this is the same as saying 4x raised to power 0 integral dx. Because x raised to power 0 is 1. Is that correct? So bring out your 4 now. This now becomes 4 integral of x raised to power 0 dx. So that will become 4 into s raised to power 0 plus 1 all over 0 plus 1 plus c. That will practically give me 4. 0 plus 1 will give me x. Now that's x raised to power 1. X to power 1 means x all over what? This is x to power 1 all over 1 plus c. This is the same thing as x to the power 1 is the same thing as x, and this is the same thing as 4x plus. So either you do this or you that derivatives cancel anti what? Derivative. Is that cool? Quickly, let's take the next question. We'll just be solving question.
Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Then this semester, you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy.
Question 4 says that we have integral. Now, you can decide to do integral of sum is the integral of the sum is the sum of the integral. So this is practically the same thing as saying integral of 2x squared dx minus integral of 5x dx plus integral of 3 dx. Integral of sum is the sum of the integral. From here now, how we should do, bring out the constant. That becomes 2 integral x squared dx minus 5 integral x dx plus 3 integral dx. This will practically give me, this is 2s raised to power 2 plus 1 all over 2 plus 1 minus 5 s raised to power. What's the power there? 1 plus 1 all over 1 plus 1. That'll give me plus. This anti will cancel out. What do I have? 3x. So this will now practically give me 2x 3 all over 3 minus 5x squared all over 2 plus 3x. Always add your constant plus constant. Are you seeing that? So that becomes the answer. If you think you are playing, if you think you are line, differentiate this, you get the question. Are you seeing that? Or you can use differentiation to be testing whether you are what? You are correct. Now let's take the next question, question 5. We are still on power rule. We have root x dx. Now this practically gives me that, first of all, what should take ds? Root x ds simply as s raised to power half ds. Is that correct? So there's no constant here. So this is simply as saying x raised to power half plus 1 all over half plus 1 plus a word constant. That'll give me s raised to power half. That's 3 over 2 now. 3 over 2 all over 3 over 2 plus c. Now, if you do that very well, I think that will practically give me 2x raised to power 3 over 2 all over 3 plus c. Are you seeing that? This is x and they will interchange, right? 2 will work. So I can practically see, I can stop there, but I can still decide to say my answer is 2 root x squared cube all over what? 3 plus c. Or you just stop here. Any of them, this is correct too. Are you seeing that? So that you not get confused. But I just presented that in this form. Quickly, let's take the next question. Question 6 say that in this kind of question, what are we going to do? Now, easiest thing to do is to expand though, so that we have a straight. This is simply as integral of x times x. That'll give me x squared. X times 2, that's plus 2x minus x minus 2 dx. So this will practically give me integral of x squared, that's plus x, because 2x minus x plus x minus 2 dx. This will practically give me, I'll just go straight. I can decide to bring them integral of sum is the sum of the integral, but I can decide to just go straight. This now give me x squared, that's x squared plus 1 all over 2 plus 1 plus x raised to power 1 plus 1 all over 1 plus 1 minus 2. That will give me minus 2x. Hope you now we got that. So that will practically give me x 3 all over 3 plus x squared over 2 minus 2x plus a constant. Oof. Do you understand that? Practically, let's go to question 7. We are just trying to solve, because the more we solve, the more our hand will be strong. So if let's expand this. This practically become integral of 1 times this will give me root v, right? V times this minus v root v a. So this is the same thing as saying integral of root v dv minus integral of v root and v dv. Is that correct? You say integral of sum is the sum of the integral. Now solving this first one, this is practically the same thing as saying integral of v raised to power half dv minus this one is practically saying integral of v, because this v is 1, this is half, that's 1 plus half dv. In this is like just like saying v times root v. According to this is the same thing as v raised to power 1 times v raised to power half. You plus the power. So that will give me practically integral of v raised to power half dv minus integral of v raised to power 3 over 2 dv. Now, let's now solve. Now, this will practically give me v raised to power half plus 1 all over half plus 1. Is that correct? Minus v raised to power 3 over 2 plus 1 all over 3 over 2 plus 1 plus the constant. That will give me v half. There will give me 3 over 2, 3 over 2 all over 3 over 2 minus, this is 3 over 2 plus 1. And that will give me 3 over 2 plus 1. That will give me practically, like say, 1 unknown bar. Let's put for the LCM there. LCM there will give me, and that will give me, that's 3 over 2 plus 1. LCM there will give me 2 abi. 2 here, 1. That's 3 plus 2. That's 5 over 2. So that will practically give me V 5 over 2 all over 5 over 2 plus C. Or I can practically say my answer is 2 V 3 over 2 all over 3 minus 2 V 5 over 2 all over 5 plus constant. That's the answer. I hope you are following me, guys. Now, let's practically take question 8. Question 8 says a lot of people have integral of 3. Now, follow me. This is integral of 3 all over x raised to power 4 dx. Now, this is the same thing as saying integral of 3 x raised to power minus 4 dx. Law of indices. So, how do I solve this now? Now, this now practically becomes, bring out your constant, that becomes 3 integral x raised to power minus 4 dx. That will become 3 into x raised to power minus 4 plus 1 all over minus 4 plus 1 plus the what? The constant. That will give me 3 x raised to power minus 3 all over minus 3. Minus 3 becomes minus 3. So my answer becomes minus x raised to power minus 3 plus c. Or I can say my answer is minus 1 all over s raised to power 3 plus. Now hold on, this is because this is s raised to power 4. Because understand when, just follow me, I'm going to show you something, but hope you understand this is just normal math. Now let's do question 9. We have integral of 2 over root x. Now this is practically saying, this is simply as saying integral of 2 all over s raised to power half dx. This is practically saying 2 integral s raised to power minus half dx. Are you seeing that? So bring out your constant. That becomes 2 integral of s raised to power minus half dx. That will become 2 into s raised to power minus half plus 1 all over minus half plus 1 plus c. That will give me 2 into 1. That will be s raised to power half all over half. Is that correct? Bracket close plus c. So this will now give me 2. This 2 will come up times 2 s raised to power what? Half all over 1 plus c. That will give me 4 root x plus. Are you seeing that? So you can differentiate that, you're going to get that. So that will give me 4 root x plus your what? Plus c. Are you seeing that? Because half, 1 minus half is half. Are you seeing that? So, and that 2 definitely what? Come up 1 divided by 2, 2 will what? 4. So practical, I've solved 9 questions now. Let's see question 10. We have this practically becomes, first of all, let's do integral of something, sum of the integral. Integral of 3 dx minus integral of 4 all over x cubed dx. This will practically become integral of 3 dx minus integral of 4x minus 3 dx. So this will practically give me 3, because this antiderivative cancels the derivative, we're going to have 3x. That will give me 3x minus, that will give me 4s raised to power minus 3 plus 1 all over minus 3 plus 1. That will give me 3x minus 4x raised to power minus a plus 1. That will give me minus 2 all over minus 2 plus c. This minus 2 can reduce this 4, right? And minus and minus become plus. That become 3 plus 2x raised to power what? Minus 2 plus c. Or you say 3 plus 2 all over x squared plus c. Are you seeing that? Please ensure you cross-check my work. Hope I didn't make mistake in numbers. 4x, that's 4x minus 3, that's 3 plus 2, that become 4x squared minus 2 all over minus 2. So 3, okay, don't see what I'm saying. This is 3x, 3x, 3x. Are you seeing that? So that become 3x plus 2 all over x. Always take your time to go through your answer. You may just make a slight mistake. Practically, let's see question 11. The question says, now, this is different. Okay, how do I know this is different? This is the same thing as saying, bring out your constant. This is 2 integral 1 over x dx. Yeah, I know some of you now say, practically, this is not giving me integral of x raised to power minus 1. No, you don't do this. So I'll take this out. Why do we not do this? There is a law of differentiation that says that if we have y is equal to in x, what's y is equal to in s? In s is equal to 1 over x. Sorry, y prime will give me 1 over x. This is logarithm law. Is that correct? So this 1 over x, so I can practically say this is now equal to 2 in x plus c. That's nice. It only happens, please keep this one side. It only happens when you have 1 over x, 1 over x, 1 over x. Because if you differentiate this now, okay, if we have y is equal to 2 in x. How do you differentiate this? This 2 is here. 2, what is in x? In s is, the 2 is here. In s, well, differentiate in s, that will give me 1 over s times 1 over x. This will give me 2 all over what? X. So they now tell you to integrate this. Integrating this now, you're going to get this. Are you seeing that? So please, if you have 1 over x always in x. What's 1 over x, everybody in x. What's 1 over x, everybody in x. I wanted to give you this so that don't confuse question of like this 2 all over x squared dx. And when you have integral of 2 all over x, it occurs when the x does not have a power. Are you seeing that? So please take note about that. Now, the last which I'm going to solve, I think, how do I solve this? This is practically the same thing as saying integral of u raised to power 3 all over u squared plus 5. There's integral of 5 u squared all over u squared plus integral of 4 all over u squared. This is supposed to be du, okay? This is du, du, du. So this square will cancel out. That will become integral of u du plus 5 square will cancel that. That's 5 integral du plus integral of 4 all over u squared du. Now, let's now go straight. This will give me what? This will give me u 1 plus 1 because the power here is 1 all over 1 plus 1 plus this one will come out. That will give me 5u. Is that correct? Because this uncle will cancel what? Anti, that's 5u. Plus this one is the same thing as 4u raised to power minus 2. That will give me 4 into u raised to power minus 2 plus 1 all over minus plus c. Is that correct? That will give me u squared all over 2 plus 5u plus 4 u raised to power minus 1 all over minus 1. So that will give me u squared all over 2 plus 5u. This will give me minus 4u minus 1 plus c. Or I can start to say u squared all over 2 plus 5u minus 4 all over u plus. That becomes the answer. Please, I have to take my time because this is the first law. It's power law. The more questions you solve, go to the notes. There are a lot of questions. I have to take my time to solve questions on power so that it gets into your brain. Are you seeing that? This is the only rule I'm going to solve 12. Others can be 4, 5, 3, and so on and so forth. I hope you understand this. You can pause it, watch, and try to solve all the questions I've solved. If you can do it on your own, it means you understand it. Are you seeing that? I'll see you in the next lesson. We'll be doing differential system. I still remember self, sir. Peace out. Bye for now.
Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.